Hello everyone, welcome to the talk. I'm Jianfeng from University of Virginia. Today I'm going to present our work intent classification and slot filling for privacy policies. This is a joint work with Wasi Ahmad and Kai-Wei Chang from UCLA, Tule and Yuan Tian from University of Virginia, and Thomas Norton from Fordham Law School. Online service providers and mobile applications might collect users' information for various purposes. And the only way users know about this is through privacy policy. In a privacy policy document, users can obtain information such as how a service provider collects users and maintains the user's information. However, privacy policies are often very long, complicated, and confusing since they are meant to be comprehensive and written by the domain experts. For example, the privacy policy shown here has more than 2,000 words and 10 different sections. Thus, a normal user usually does not read it. As a result, users might not be aware of their data being sold to third-party advertisers, even if they have given their consent to do so. Therefore, automating information extraction from verbal privacy policies is important since it can help users to understand their rights and make informed decisions. In the literature, information extraction from policy documents is formulated as text classification, text alignment, and QA. This works annotate privacy policies at the sentence level without further utilizing the constituent text bands to convey specific information. For example, in the QA system for privacy policy shown here, only the relevant long sentences are retrieved. Users might not be able to identify the information they are interested in quickly. In this case, if we are able to extract finer-grained information, such as short text bands, then we are able to pinpoint the exact information users want and facilitate a detailed document analysis for the downstream tasks, such as codify policy enforcement. Usually, sentences written in a policy document describe a specific privacy practice, and the constituent text bands show the details of the practice. For example, in the sentence, we may also use or display your username and icon or profile photo or marketing purpose or press releases. The sentence describes the privacy practice, data collection or usage, and there are several semantic roles associated with the sentence. For example, marketing purpose or press releases is the collection purpose, and username is the collected data. By formulating our problem in this way, we create a corpus called Policyle to achieve our goal. In our formulation in Policyle, we refer identifying the data practice of a sentence in a privacy policy as intent classification. We consider 4 different types of privacy practices: data collection or usage, data sharing or disclosure, data storage or retention, and data security or protection. The intents we choose cover the content which privacy policies usually care about most. We also consider the intent type other, which represents those privacy practices that do not fall into the above 4 categories. In the example we just described, the intent is data collection or usage, which describes what, why, and how user information is collected. Given the sentences annotated with intents, we are also interested in identifying the text bands in sentences that explain specific details about the practices. We refer the identification of such text bands as slot filling. In our formulation, we care about 2 types of slots. The first one is type 1 slot, and it includes participants of privacy practices, such as data provider and data collector. The second one is type 2 slot, and it includes purposes and conditions that characterize more details of the privacy practices. Slots might be associated with a list of different attributes. For example, data provider could have the attributes user and third-party entity, and data collected could have the attribute location data and demographic data. In the example we just described, the slots are data collector with attribute first-party entity, the action of the privacy practice, the data provider with attribute user, the data collected with attribute user online activities or profile, and the purpose with attribute advertising or marketing. The color text shown here is the corresponding text band of the slots. Overall, our collected corpus Policyle is an English corpus over 31 website and mobile app privacy policies with more than 5,000 intent annotations, more than 11,000 slot annotations, 5 different intent types, 14 type 1 and 4 type 2 slots with more than 20 slot attributes. The corpus is annotated by domain experts such as law school students. In order to extract fine-grained information such as intents and slots, we provide 2 modeling strategies. The first one is based on the sequence tagging approach. Given a sentence with words W1 to WL from a privacy policy document, a special class token is prepared to form the input sequence. The input sequence is then fed to an encoder, and the encoder produces contextual representations of the input token H0 to HL, where H0 is fed to an intent classifier to predict the intent label, and H1 to HL are fed to the slot classifier to predict the target slot labels. We train the models end-to-end by minimizing the cross-entropy loss of both classifiers. We also optionally use conditional random field to perform the slot labeling tasks. The second approach is based on sequence-to-sequence learning. Given the label information of the sentence, we first form the target sequence using the template on the right side. We can see the template starts with the intent label, and the slot labels follow accordingly based on the relative precisions of their test beds. During inference, we use greedy decoding and parse the decoded sequence to extract intent and slot labels. Note that since our proposed Policyle corpus consists of a few thousand examples, instead of training the sig-to-sig models from scratch, we fine-tune the pre-trained models as baselines. We then conduct experiments to validate the effectiveness of the proposed approaches on our corpus. We choose 5 different encoders for the sequence tagging method. We're embedding by LSTM, Transformer, BERT, and Robota. Note that sequence tagging models might also include CRF for slot filling task. And we also use 5 different sig-to-sig models: mini language model, unit language model version 2, mass, and BART. We use F1 score as the metric for both intent classification and slot filling tasks. For slot filling, we also use ism match as an alternative metric. Now we present the results of sequence tagging. The results of intent classification are shown in the figure on the right side. We can see the model performance increases with the model size. As for the slot filling task, we show the type 1 slot F1 of different models on the left side and the type 1 slot exact match on the right side. Note that type 2 slots share the similar results. We can see that model performance of slot filling increases with the model size in general as well. We also see that slot F1 and exact match increase when the CRF is applied, which indicates CRF helps slot filling. For sig-to-sig models, we observe that BART performed the best among all models. We compare the best performing models, Robota with CRF and BART from both approaches, and the results are shown on the right side. We can see that for intent classification, the 2 approaches are competitive, but sig-to-sig models outperform the sequence tagging models in slot filling by a large margin. In order to understand why this happened, we further break down the performances. On the left side, we see that BART outperforms Roberta regardless how long the slots are in terms of record score. On the right side, we see that Roberta is bad at predicting slots such as the polarity of the pricing practice, protection methods of the user data, and the storage place of the user data. Combining with the analysis of the data statistic of our corpus, the sequence tagging approach is not good at predicting slots with lowest amount of annotations. In summary, we present Policyle, the first intent classification and slot filling corpus with fine-grained annotations in the privacy policy domain. For more information of our work, please check out our paper and codes. Thanks.